In this video, we're going to learn about how to use 3 keywords in experiments. These are accuracy, precision, and reliability. Let's consider these by taking part in a game of darts whilst doing a chemistry experiment. In a game of darts, you want to aim for the centre of the dartboard, called the bullseye. In a chemistry experiment, you aim to measure the volume of a gas. You aim for your measurement to be close to the true value found by an independent scientist. In both cases, you have 3 chances. Imagine you throw 3 darts in round 1 and they hit the dartboard like this. You also measure your volumes of gas. What do you notice about where each dart has landed and the volumes of gas collected? Pause, think, and continue. The answer is that all of your darts have hit the bullseye. We would say your throw in this round is accurate. In your experiment, however, all of the results are close together, but we're not sure what measurement is the true volume of gas collected. To make this measurement more accurate, you can take an average. How do you do this? Pause and continue when ready. The answer is, you add the measurements and divide the total by the number of times you measured the volume of gas collected, which was 3 times. You have now made this measurement more accurate. Several independent laboratories have done this experiment and recorded results in the region of 50 cubic centimetres, so your result would be considered accurate as well. If you look at the darts again for this throw, there's hardly any difference between where all 3 darts have landed in the bullseye, and there's very little difference between your measurements and the average. This makes this round's throw and your measurements of the volume of the gas collected precise. Imagine in the second round, your 3 darts hit the dartboard differently and your volumes are also different to those measured in round 1. What might you say about their accuracy and precision now? Pause, think, and continue when ready. The answer is, you weren't very accurate, because all 3 darts have landed away from the bullseye. However, the darts are still precise because they have landed in similar places. Your second set of measurements for the volume of gas collected are no longer accurate as well. You'd hope to get the same set of results if you did everything the same way twice. However, these results are precise. All of your gas volumes are similar to one another and the average. Here's a challenge. The results are reliable for an experiment when the measurements made can be repeated by you and by others independently. What would you say about the reliability across round 1 and round 2 in the game of darts and the experiment? Pause, think, and continue when ready. The answer is that your dart throwing ability across these 2 rounds, unfortunately, has got worse and was not reliable. Your experimental results are also unreliable. In summary, accuracy is how close your measurement is to the true value. It can be improved by taking an average of your closest measurements. Precision is how close each measurement is to each other and the average value. And finally, a measurement is reliable if the measurements can be repeated by you and are found to be similar to someone else who has done the same experiment.